So we're going to look at number 19 from lesson 4. And I think if I do this, I can just grab a window and paste. Now, I am going to say I like this question. I'm not saying I like this question, I like this question, I like this question. This same procedure would be used to decide how far in front of a road hazard we put the warning sign. You would work your way backwards. So a car is traveling at 20 meters per second. 20 meters per second. Could you multiply that by 3.6 and convert it to kilometers per hour? I just want to see how fast we're going. Anybody on their calculator, which you have out in front of you by now, could you multiply 20 times 3.6? How fast is that? Okay, so you're on the low heat, let's say. You're not on a subdivision unless you're driving stupid. Okay? Yep. So, and the driver sees a child standing on the road. Yes, I'm putting a child in peril. The driver takes 0.8 seconds to react because it takes time for your foot to move from the gas pedal to the brake pedal, and then steps on the brakes and slows at 7 meters per second squared. Slowing fairly quickly, not quite 1G, but you would feel like you were getting pushed forward. This isn't a panic stop, this is definitely a power stop. How far does the car go before it stops? Okay. Well, what's this question want me to find? Yeah, and we're going to get a displacement technically, but sure, D, I'll go D equals question mark. What's that 20? Hang on here. I need to visualize what's going on. Car. Person. Okay? Here's what I think is happening here. I think the driver continues going for a certain distance, and then right here is where they hit the brakes. And this section is where they're slowing down. I think I'm going to find this distance, I'll call it D1. And this distance, I'll call it D2. Because, Deegan, it seems to me there's two sections here. While you're coasting before you hit the brakes and once you start decelerating. And now I'm going to carefully read and decide, can I put the data here or here? So that 20, it's definitely a velocity. I think it's a VI, and I think it's before we hit the brakes. .8 seconds. That time, is that the time of before we hit the brakes, or is that the time it took us to come to a stop? Okay, so I think this T is going to go right here. I got two things. If I find three things, I can find a third. I find a fourth. What's this 7? It's an acceleration, meters per second squared. Although slows down, I probably would have put a negative in front of it just to remind myself it is going to be negative. Is that 7 before I hit the brakes? -7 before I hit the brakes or after I hit the brakes? So over here, stops. Which side? Before brakes or after? Alessio, right now, how many things do I know before I hit the brakes? How many things do I know after I hit the brakes? Not enough. What else do I know? What? You're saying VI is 20 here as well, because this whole time, since I haven't hit the brakes yet, I'm still traveling 20 right there when I start to tap on the brakes? Okay, that gives me three things. I can find a fourth. What about this section here? In this section here, am I speeding up or slowing down? Here? Here? Constant. So if I'm at a constant speed, what's my acceleration exactly as a number? Let's make it even. Let's say it's cruise control. Driver was on cruise control. Oh my goodness, I need to hit the brakes. Okay? So I think I can find both distances. I can find the distance while we're still coasting, and then while we are braking. Which equation has an A of VI? You know what? I think I can use this. D equals VIT plus a half AT squared. But what's A equal to? So this whole term vanishes. This is the equation we used in the distracted driving activity. We all got to yell at each other. The one that Annika hated. So before we even hit the brakes, we're going to travel 20 times 0.8. I can do this in my head, Aiden, because that 0 and that decimal cancel themselves out. This is really 2 times 8, which in your head is? Okay. Braking. I think now I'm going to use VF squared minus VI squared all over 2A. 0 squared minus 20 squared all over 2 times negative 7. 0 squared minus 20 squared all over 2 times negative 7. And 28.6 meters. Yep. 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 I'm going to write 28.6, but guess which button I'm going to use on my calculator, Aiden? Darn right. More accurate, less error, less typing, triple win. Dope. I hit 6 plus answer. Add the extra 10 in there, Mr. Duick. And you get 44.6, which I hope is what the answer key said. Yeah, there you go. So replace child in the road with road hazard, and this is how you could work out where you need to put the warning sign so people have enough time to either come to a stop. And then you'd probably put it further forward than that as well. You'd build in some healthy error margin. You'd assume some people have a slower reaction time. You'd probably assume some people were speeding even faster than this. Certainly if it was on the low heat, you'd probably say, late at night, some people are doing 100. Idiots, I'll make sure I plan for that just in case. Is that all right? So I had a few of you ask me that one, and I told you I'd let you think about it. I think I helped 1 or 2 of you, but the rest of you, I said, I'll come back to that. Annika, did I show you anything new? Hope not. Where I was clever was realizing I had to break it up into before braking, after braking, and maybe the biggest aha was to realize, A is 0 when you're not braking, constant speed. That notion of acceleration being 0 when you're at a constant speed, worth having in your back pocket. It's going to come in handy for the remainder of the year as well. Were there any questions from the Lesson 6 free fall homework? Just for the record, and be honest, I'm not writing this down. How many of you have not finished Lesson 6 free fall? This is just going to guide. Okay, so most of you have not. Okay, then I'm going to pause for a second.